Hestia is the well-known Greek goddess of the hearth. She commands fire and heat. A new plate heat exchanger is now born that bears the name of Hestia. With increased attention on the environment, the power generation industry demands that components function efficiently and reliably, even under severe conditions. This is especially important and challenging for heat exchangers. To meet these demands, a joint development effort by HISAKA Works and Hitachi GE Nuclear Energy has taken heat exchanger performance beyond what has previously been considered possible. The Hestia NX-50 is the result, surpassing the temperature, pressure, and life cycle limitations of its competition. Plate heat exchangers have generally outperformed other designs due to their smaller size and superior maintainability. Consequently, they can now be found in a broad range of industrial applications. Gaskets have been the limiting factor, preventing further performance improvement. That is, until now. HISAKA Works and Hitachi GE Nuclear Energy overcame the limits of traditional single gaskets with a new and innovative concept, the Hestia NX-50. This plate heat exchanger transcends the performance of conventional heat exchangers. The traditional single gasket pressure boundary was abandoned and replaced by an innovative two-gasket system, incorporating intergasket leakage detection. The result is the Hestia NX-50, employing the world's first double-gasketed line design. Rubber gaskets usually fail due to cracking caused by atmospheric oxidative degradation. This degradation is dramatically accelerated at high temperature. Oxidation, high temperature, and radiation exposure all can result in polymer cross-linking and molecular scission, thereby changing the properties of the polymer and stiffening the normally pliable gasket. A variant of EPDM has been developed which maintains its properties even under stress from extreme heat and chemical reaction. A key feature of the Hestia NX-50 double-gasketed design is the manner in which the outer gasket protects the inner gasket from atmospheric oxygen, extending its life. The plate structure and groove design ensure the gaskets are completely confined by adjacent plates and remain stable against design basis fluid pressure. These factors contribute to the Hestia NX-50 reliability. A failure of the inner gasket does not lead to a breach of the pressure boundary, since both inner and outer gaskets must fail to lose component pressure integrity. Moreover, a detection penetration located between the inner and outer gaskets alerts plant operators that the inner gasket has been compromised. These innovations enable the Hestia NX-50 to perform at temperatures up to 250 degrees Celsius and pressures in excess of 9.5 megapascals, well beyond traditional plate-type heat exchangers of the past. Hitachi GE Nuclear Energy's Hustle facility was employed to demonstrate the Hestia NX-50. Hustle is a thermal hydraulic test facility that can replicate the actual operating conditions encountered in nuclear generating stations. The Hestia NX-50 also demonstrated superior performance while undergoing thermal cycling. The Hestia NX-50 proved itself when subjected to thermal cycling between 182 degrees Celsius and room temperature. These temperature swings are representative of challenging reactor shutdown cooling operations. Pressure resistance and seismic performance was further enhanced through structural improvements, including reinforced plates, support structures, and additional tie bolts. Under high temperature and pressure conditions, the Hestia NX-50 achieved a lifetime 5 times longer than HISAKA's conventional plate heat exchangers. This improves maintainability because gaskets must be replaced less frequently, reducing total downtime of the unit. In 2013, the HISAKA Works Hitachi GE Nuclear Energy Team won the prestigious ASME Power Award for heat exchangers. The Hestia NX-50 is suitable for high temperature and pressure fluid systems found around boilers in thermal power plants, for the corrosive and toxic conditions found in chemical processing plants, and for the most demanding and severe conditions found in nuclear power plants. The Hestia NX-50 is best described as the new standard in plate heat exchangers.